It wouldn't be much of an object-oriented programming language if we didn't support inheritance. Now, keeping with our theme, we aren't going to get real deep into exactly what inheritance is, but instead, I want to focus in on the concept that we could actually spend hours talking about what inheritance is. I'm going to sort of summarize all of this in one slide. We'll link to some additional resources if you wanted to dig deeper into exactly what inheritance is. What inheritance is it's a generalization specialization. That what I'm going to do is create an is-a relationship. So if we take a look at the first example of student is a person, person is very general. That's you, that's me, we're all people, we're all persons. Student is going to be a specific type of person. So it's a specialized person. Same thing then if we bring this down into a little bit more of a programming construct where we've got SQL connection and MySQL connection. In both of those cases, those could be types of database connection. And the great part about creating a generalization specialization relationship is the fact that I can then count on the generalized code, maybe things like talking to the network and otherwise, all being in that general class, and then I can add on whatever specialization code it is that I might need. I'm going to differentiate this from composition, which creates a has-a relationship. So a student has a class, for example, so they attend classes, or a database connection has a connection string. So that connection string might have like the name of the server, username, password information, etc. So has a relationship, done with properties. My is a relationship, that's inheritance. So let's talk a little bit about this in action. One thing that we want to highlight right away is the fact that all methods in Python are virtual, which means that we're always going to be able to override them. We're always going to be able to redefine their behavior. We're going to notice that we've got the keyword super to be able to access the parent class. We are going to need to do this in the constructor. Notice that bottom little line there, must always call the parent constructor. And we're also going to notice that if there's anything that's going on in that super class, some like field or a property or maybe even a method that I might want from that super class, then I can go access that by using that super keyword. Let's see a real quick little code example here. You're going to notice that just like before, I've defined a class called person. Now, I didn't do anything really fancy here. I went ahead and set up the constructor just like we had last time, added in the little method just like we had last time. That's it. All this code we've already seen. Down below is where I'm going to inherit, and there's a few things that I want to highlight in here. First of all, in order to indicate that you're going to inherit from a class, you indicate that parent class in parentheses right after the name of the class. So now I've got my is a relationship, student is a person. Now what you're going to notice is that I've got my constructor here, and on my constructor, I'm going to go ahead and specify all my parameters. So self just like before, and then what I've got is the name and, in my case, the school. Now, name actually comes from person. And one of the things that Python insists on is when you derive from a class that you are going to need to call the parent constructor if there's anything there that needs to be able to be set up. So in my case, I need to set up that name. So what you're going to notice is that I'm going to call super right here, and then I'm going to call that constructor by saying underscore underscore init underscore underscore. That's going to allow me to call the constructor, and then I can pass that name up there. So whatever name it is that you give to the student, that's actually going to be passed up to the person to give me the ability to set that property up. Then anything that's specific to student in my case, the school, we'll go ahead and set up, and then I can add on additional functionality. So you'll notice that if I decided to go ahead and use this, so I set up a brand new student, passed in the name, passed in the school, I said, say hello, I said, sing the song, we would notice that it would then go ahead and print out Hello Christopher, and then the song of Ode to UMD. University of Minnesota Duluth, by the way, not Maryland. The other thing that you're going to notice with classes is I can do a little bit of a what are you? So I can say, hey, is this an instance of additional classes? So here's that little variable that I've got. I can say, hey, are you a student? Well, we know that it is, so it's going to return true. We would sort of expect that. You're also going to notice that we can say, hey, are you a person? Well, remember, with inheritance, we're creating an is-a relationship. Student is a person, so this is actually going to return true. Last but not least, I can explore the hierarchy. So you'll notice that I can say is subclass, is student, a subclass of person, or in other words, does it inherit? And the answer to that question is yes. So if we break this down here, what's going on is there is the say hello, whoops, there is the say hello, there is the sing the school song. The other ones down below here, let me just real quick arrow to each one of those here. The top one is this a student? It's true because it is. The next one here is this a person? And again, that is true because we inherited from it. And then last but not least is this a student, a subclass of person? And the answer to that is yes, because of the fact that we inherit. Now, it's also worth noting the fact that in Python, every single class that you create automatically inherits from object. Object being that base inside of Python. Now, because of the fact that we all inherit from the same base, and that base has some functionality, we can always override that behavior. So going back to our prior example, if we maybe wanted to override say hello, so for our student maybe it says I'm a tired student named, and then whatever the name is, we could go ahead and do that. We can also override those functions that we wind up getting from that core parent. And you'll notice, and we'll link to the docs inside of the GitHub repository, the fact that we have a lot of really neat functions that are going to enable some really nice functionality. For example, one of the most common ones is this __str__. And what this does is it can now automatically convert this to a string. So anywhere where we need a string, this can now become a string. So you'll notice that what we've done here is we've now defined, or really overridden, that __ string. And when we do that, and we now go ahead and say print presenter, it's now going to print out Christopher. The reason that it's able to print out Christopher is because we overrode that __ str. That's basically our toString. So now Python is going to know how to convert an instance of our object into a string. So in a nutshell here, inheritance is going to create that is our relationship. We indicate what it is that we want to inherit from by just simply going ahead and putting the parent class inside of parentheses. We can always override functions, including the ones from that base object, and you'll notice that we can always add on our functionality, and if there's anything from that parent class that we need, we can go grab that from super. Let's go in and take a look at a demo to help bring all of this together.